So today we're going to look at kind of how reflections work on a graph. So a couple things to keep in mind about reflections to start is reflections preserve distance, they preserve angle measure, and they map all the points of a pre-image to one and only one corresponding point of the image, right? So based on what we talked about yesterday, this fits the definition of a rigid motion. So if I look at reflections, right, I look and say, well, this is what tells me I'm reflecting, right? Capital R is reflection. This tells me kind of my over what. And this is my kind of what shape. So if I look at reflecting, right, sometimes I'll just start by graphing the points, right? So like -3, 4. I have point A, 0, 1. I have point B, and 4, 2. I have point C, right? And so I connect these, and I have my shape. So then I look at kind of the y-axis, so I'm going to make myself just kind of a red dotted line to say this is what I'm reflecting over. And so for this case, anytime you have a horizontal or vertical line, easiest thing to do is say, okay, how far away from that line am I? And then kind of mirror it on the other side. Right, so if I look here, I'm 1, 2, 3 away. So I'm going to go 1, 2, 3 away over here and get A prime. Here, look, I'm 1, 2, 3, 4. So I go 1, 2, 3, 4 away. Get B prime, or no, sorry, C prime. Right, and then B, because it's on that axis, I'm going to keep B right there. And then I have my reflection. So we'll look at two more examples, right? So both of these we're going to start with the same points. So I'm just going to go ahead and graph those really quick. So you have A, B, and C. So I kind of have that triangle. And then I look at, I'm reflecting over x equals 2. So x equals 2 here. And that's going to be that vertical line. So I do the same kind of thing that I did before, right? Looking at how far away from that line is it, and kind of mirroring it on the other side. So look here, because A is right on that line of reflection, it's going to stay there. So this will be my A prime. All right, now look at B is 1, 2, 3 away. So I'm going to go 1, 2, 3 away over there. Get B prime, and C is 1, 2, 3, 4. So I go 1, 2, 3, 4, and C prime. Right, so I have my reflection shape. So now this next one, as I get kind of these points plotted again, right? So A, B, and C. Now I'm looking at what is the graph y equals x, right? So y equals x is the kind of slanted line that goes right through the origin. And so now when I look at this, right, I can't really count distances anymore because now I'm talking diagonally and that distance isn't 1. So what's going to actually happen here is that x and y flip, right? So if I say, well, A is 2, 2, A prime, if I flip that, is 2, 2. Well, that should make sense, right? Because A is on the point of reflection, right? But what happens when I look at B, right? So B is 4, -3. So for B to flip, for B prime, come -3, 4, right? And so I look and say 1, 2, 3. There, and I have my B prime. And then C is -2, -1. So C prime is going to flip that, -1, -2. And so when I graph that, right? I end up down here. Oops, that was a terrible line. And so I have kind of my reflection image. So y equals x, x and y flip, nothing happens. One thing that you might want to add kind of the bottom here is that if it's the reflection over y equals negative x, right? X and y flip, oops. And change the sign. Right, so now y equals negative x, which you'll see one on your classwork for that. X and y flip and change the sign.